Welcome to a new era of building management, where fault detection and diagnostics, or FDD, is transforming how we maintain and operate our facilities. In today's video, we'll explore how FDD, as an advanced feature of modern building management systems, automatically identifies, reports, and even predicts faults or performance issues. This technology not only enhances reliability, but also reduces downtime and supports preventive maintenance. Let's dive into how FDD is elevating building operations and why it's becoming an essential tool for facility managers everywhere. What exactly is fault detection and diagnostics? FDD is a two-part process. First, fault detection identifies any abnormalities or deviations from normal operation in building systems. Then diagnostics steps in to determine the cause or origin of the fault. By transforming raw sensor data into actionable intelligence, FDD empowers maintenance teams to act quickly and efficiently. This means less guesswork and more targeted solutions, making building management smarter and more effective. One of the standout benefits of FDD is its ability to catch issues early. Early detection reduces equipment damage and energy loss, saving both time and money. By identifying problems before they escalate, FDD helps avoid costly breakdowns and ensures that building systems run smoothly. This proactive approach not only protects valuable assets but also keeps operations efficient and reliable. Predictive maintenance is another major advantage of FDD. Instead of waiting for equipment to fail, FDD enables maintenance teams to anticipate and address issues before they become serious. This predictive capability avoids unexpected breakdowns, reduces downtime, and extends the lifespan of critical systems. It's a smarter, more cost-effective way to manage building operations. FDD doesn't just benefit the building itself, it also enhances comfort for everyone inside. By quickly resolving environmental issues such as temperature fluctuations or air quality problems, FDD ensures that occupants enjoy a consistent and pleasant indoor environment. This leads to higher satisfaction and productivity for building users. With FDD, decision-making becomes data-driven. Maintenance teams can use detailed analytics to perform root cause analysis, enabling them to address the underlying issues rather than just treating symptoms. This approach leads to smarter planning, more effective repairs, and a significant reduction in reactive maintenance. FDD shifts the focus from reactive to proactive maintenance. By identifying potential issues early, teams can plan maintenance activities in advance, minimizing disruptions and ensuring that resources are used efficiently. This proactive mindset leads to better outcomes for both the facility and its occupants. Let's take a closer look at how FDD operates within a BMS. The process begins with data collection. Real-time monitoring of sensors, controllers, and meters provides a constant stream of information about building systems. This data forms the foundation for detecting and diagnosing faults, ensuring that nothing goes unnoticed. Once data is collected, FDD uses rule-based algorithms or artificial intelligence to analyze it. Traditional systems rely on if-then rules, such as flagging a possible valve issue if the chilled water return temperature is too high. Modern systems go further, using machine learning models to detect complex patterns and predict faults before they occur. When the system detects values that are out of range or mismatched, it generates a fault. Alerts are triggered automatically, notifying maintenance teams of potential issues. This immediate notification system ensures that problems are addressed quickly, reducing the risk of further damage or downtime. After a fault is detected, FDD systems move to diagnosis and reporting. The system suggests possible root causes, such as indicating that low airflow may be due to a blocked filter. This targeted reporting helps maintenance teams quickly identify and resolve the underlying issue, streamlining the repair process. Let's look at a real-world example. In an air handling unit, if the cooling coil isn't effective, FDD might diagnose a stuck valve or a chilled water flow issue. By pinpointing the exact cause, maintenance teams can fix the problem faster and prevent further complications. In variable air volume systems, FDD can detect low zone temperatures even when the damper is open. The system may diagnose a thermostat miscalibration or actuator failure, allowing for precise corrective action. This level of detail ensures that comfort and efficiency are maintained. For chiller plants, FDD can flag high power consumption and diagnose issues like a failed condenser or poor sequencing. By identifying these problems early, the system helps maintain energy efficiency and prevents costly downtime. In fan coil units, FDD can detect no airflow and suggest causes like a dirty filter or motor issue. This rapid identification allows for quick fixes, ensuring that air quality and comfort are not compromised. FDD data isn't just hidden in the background, it's visualized in the BMS front end. Heat maps show fault density by zone, while color-coded dashboards make it easy to spot issues at a glance. Fault logs with timestamps and status updates help teams track progress and resolution, making the entire process transparent and manageable. To measure the effectiveness of FDD, key performance indicators are tracked. These include mean time between failures, MTBF, fault frequency, and downtime trends. Monitoring these KPIs helps facility managers assess system health and identify areas for improvement. FDD doesn't operate in isolation. It integrates seamlessly with maintenance workflows by automatically generating work orders when faults occur. Maintenance teams receive email or SMS notifications with diagnostic details, and fault logs are linked to asset management systems for comprehensive tracking. Modern FDD systems leverage artificial intelligence and machine learning to take fault detection to the next level. These advanced systems can detect patterns before a fault even occurs, recommend fixes using predictive analytics, and continuously learn from past faults to improve accuracy over time. By learning from every detected fault, FDD systems become smarter and more accurate. This continuous improvement means fewer false alarms, faster resolutions, and a more reliable building management experience for everyone involved. Summary: FDD elevates the role of building management systems from simple monitoring to intelligent decision-making. By identifying problems early and offering root cause insights, FDD minimizes energy waste, extends asset life, and improves overall facility management outcomes. As technology continues to advance, FDD will remain at the forefront of smart, efficient, and reliable building operation.